Here we want to look at what we call a literal equation. Now, basically what we're talking about with literal equations is just an equation, and really what we've got is usually, most of the time, it's a number of pronumerals in the equation. So a lot of times they're formulas, and it's about rearranging the formula. So let's start with something like E equals mc squared, which you've probably heard of, that statement. Now, if we look at this, we say in this one that E is the subject, because E is in terms of everything else. Okay, so E is the subject. What do we need to do if we want to make M the subject, though? So what we need to do is rearrange our equation. So if we start with the E equals mc squared, and we want to make M the subject, means we want to make M by itself. So what we need to do would be divide c squared on both sides. So therefore, M would equal to E on the c squared. So M's now the subject. And that's what we're talking about when we're doing what we call a literal equation. We're getting one equation in terms of and one variable in terms of everything else. So if we look at another example, something similar is like speed is equal to distance over time. So if we've seen that one before, the speed is equal to distance divided by time. Now what happens if we want to make t the subject? So this time we'd have to multiply both sides by t to start off with. So st would equal d. And now to get t as the subject, we have to divide both sides by s. So t then would be equal to d over s. So we've gone from the situation where s was the subject now to where t is the subject. So that's what we're trying to do with those types of equations. As I said, a lot of times they're formulas. This one is one we use in the seniors. So Tn, and it's actually what we call the sum, the term of an arithmetic progression. So a plus n minus 1 times d. So as you can see, there's 1, 2, 3, 4 variables there that we can, at the moment, Tn's our subject. But what about if we wanted to make d our subject? Well, what do we need to do? We need to get d by itself. Firstly, what we need to do would be to subtract a. So we're rearranging this one. Tn minus a is equal to n minus 1 times d. So to get d by itself now, we need to divide both sides by the n minus 1. So divide there by n minus 1. So therefore we could write it as d, and it doesn't matter whether d is on the left or the right hand side. It doesn't matter at all. D would be equal to Tn minus a over the n minus 1. So there's a little bit of playing around with that. There's a number of steps. So, but again, it's just like basically saying, okay, what if we had to solve for d? What if we substitute values in for Tn, a, and n, and we had to solve for d? We'd have to play around and organise our numbers there. Let's have a look at one more example where we can see that we can do almost anything we like with it. This one's what we call compound interest. A equals p outside of 1 plus r to the power of n. Now what if we want to make r the subject? So we want to get r by itself. There's a little bit of playing around to go on with here. So we need to do some manipulation. The first one is that we've got p times this statement. So divide both sides by p. So divide by p there would give us the a over p equals to 1 plus r to the power of n. Now a on p is equal to all that part to the power of n. So, and I want to get r by itself, so I need to get rid of that power of n. So what I need to do is actually take the nth root of both sides. Because taking the nth root is the opposite of putting to the power of n. So that's going to leave me 1 plus r there, because they're going to basically cancel each other out. And I'm going to get the nth root of a over p. Starting to look a little bit messy, but this is what we need to do to get r by itself. Last step is to subtract 1 off both sides. So we can write r equal to the nth root there of a over p and that's all minus 1 there, subtracting 1. So we get r by itself. So all of these ones, what we call literal equations, basically working with pronumerals, but we're solving them like we would normal equations. You're just doing the opposite operations like we've done all the way through. So try not to panic too much with it. Just look at what's happening to the variable that we need to solve for, and then reverse all those operations that you see as you go along.